Today we're going to get into our unit about polynomials and operations with them. Before we get into polynomials, though, we want to start with monomials. So monomials are, it's either a number, a variable, or a product of numbers and variables. And some examples of monomials are 5x, 3x squared, 9x squared, y to the 7th, negative 5/2, x, y to the 4th, and negative 6/11. Okay, so these are all examples of monomials. Monomials with the same variables and exponents are called like terms, and that's something we've talked about before. To add or subtract monomials, you need to combine your like terms. You do not change the variables and exponents. Okay, so this is something we kind of talked about at the very beginning of the year. We're bringing it back now. So to add and subtract these monomials, you are not touching the variables and the exponents. We're only looking at the numbers in the front. So I'm really just looking at 17 minus 25. And 17 minus 25 is negative 8. And I'm going to just bring down my like term of the x. So my answer here is negative 8x. Okay, so same idea for number 2. You have y squared and you have y squared. So we're going to ignore that because they're the same. We're really just doing negative 23 plus 6. And negative 23 plus 6 is equal to negative 17. Now, it's not negative 17 as our answer because we still do have the y squared. So I'm just going to bring that back down. Same idea here. Our variables is a cubed, bc, a cubed, bc. So I'm just looking at the numbers in front. Negative 15 plus 6, negative 9, and then a cubed, bc. For number 4, we have 38 x squared y minus x squared y. Remember, this is like saying we have 1 here. So I'm doing 38 minus 1, and that gives me 37 x squared y. So try 5 and 6. For 5, you should have had, since we have AB and AC, you can't do anything here. So our answer just stays the same. But for 6, they are like terms. They have MN and MN. So negative 8 plus 9 is 1. So you can either write it as 1 MN, or I'm just going to write it as MN. All right, for number 7, so this is the same idea. Yes, it's a fraction. Fractions are okay. You don't need to be scared of using fractions. If we're going to subtract fractions, however, we do need to go ahead and change those to like terms. So to get them as common denominators, I'm going to go ahead and multiply both parts of this by 3 and both parts of this by 5 to get a common denominator of 15. So I'm going to do 2 times 3 is 6, and then 5 times 3 is 15. And then 1 times 5 is 5, and 3 times 5 is 15. So now I'm just doing 6/15 minus 5/15, and I know that that is 1/15. And I'll bring over CD squared. Right, try 8. For 8, you should have gotten negative 50 x to the 4th, y to the 3rd. So for number 9, it's a little bit different here. We're not just working with just one like term. We actually have 2 different sets of like terms. So remember when we would highlight and we'd select our like terms? I'm going to do that here. So I have my y terms. Make sure you're including that sign in front of them. And my z terms. So I'm doing 3 plus 4 to get 7y, and 9 minus 3 to get a positive 6z. Same idea here. I got my b terms. I got my a terms. I only have one a term, so I'm just going to go ahead and write 8a. And then I'm going to go ahead and do 12b minus 10b. 12 minus 10, I know, is 2. So it's plus 2b. Okay, and when you're writing these, make sure you're writing them in alphabetical order. So whatever letter comes first in the alphabet is what you need to write first. Okay, and then same idea here. And when you're writing them with exponents, the higher exponents always go first. So I'm going to go ahead and highlight. I'm going to do my w squared terms. And I'm going to do my 9w and my negative 31w. Okay, so I have 13 plus 4, and that's 17w squared. Since the higher exponent is the 2, that one's going to be the one I write first. And then 9 minus 31 is negative 22. All right, so let's go ahead and look at number 12. 12, I've got m squared n, I've got mn squared, and m squared n. So make sure we're identifying our like terms. So my m squared n's are going to be pink, and my mn squareds are going to be yellow. So I can go ahead and combine my terms now. Since m alphabetically is first, and m has the higher exponent, I'm going to do the m squared n's first when I write them. So 10 minus 1, that's 9, m squared n, and then I can just go ahead and bring down my 7 mn squared. Okay, for these last ones, you're finding the sum, and if you remember, sum means we're adding. So go ahead and add this and see what you get. When you go ahead and add 16 plus a negative 5, you get 11, and then you bring down the y squared. For 14, your keyword is difference. Remember, difference means subtract, so go ahead and try this. When you go ahead and subtract these, you get your 10 minus your 2 to get 8, and then you just bring down that like variable monomial. So 15, go ahead and try that. Okay, so when it says subtract 9a from a negative 15a, that means we're going to write negative 15a minus 9a. And when we go ahead and do that operation, we get negative 24a. So same idea here for 16. From this number, we're subtracting that. So from this, we're starting with this. We're going to subtract that. So negative 9cd squared minus a negative 2cd squared. You know, when you subtract a negative, same thing as adding the positive. So we're doing negative 9 plus 2, which is negative 7cd squared. Now, that was adding and subtracting. When we're multiplying, you need to use the product rule. So the product rule is saying if you have x to the a times x to the b, you're really doing x to the a plus b power. So, for example, we have x to the second times x to the third. So that's really telling me that I'm doing x to the 2 plus 3, and x to the 2 plus 3 is x to the fifth. Okay, so you're just adding the exponents. For the product rule, when you multiply monomials, you add the exponents. So we're going to go ahead and add our exponents right here. This is 9a to the 9th power times a to the first power. When it's not listed, that's just to the first. So we're doing 9 plus 1, and 9 plus 1 is 10. And then here we have w to the 7th times w to the 4th. So you're doing 7 plus 4 to get 11. Okay, so that's just if you have a coefficient of 1. But typically you're going to have an extra coefficient. So what you need to do is you're going to multiply the coefficients and then simplify the variables with the product rule. So I've got 4x squared times 3x to the fifth. Now this product rule only works for multiplication. You cannot use it for any other operation. Okay, so I'm going to go ahead and multiply my coefficients. So I'm doing 4 times 3, which is 12. And then I'm taking my x, and since it's multiplication, I know I can add my exponents. So I'm going to do 2 plus 5, which gives me 7. Okay, so the next one, we have 3x to the 6th times 5x to the second power. So I can go ahead and multiply my coefficients first. So 3 times 5 is 15. And since I have x terms, I'm going to do 6 plus 2, which gets me 8. Go ahead and try the next one. When you go ahead and solve 22, you're doing 5 times 6 first to get 30. And then 2 plus 4 to get 6. Okay, so same idea for these next ones. Even though there's more variables now, it's the same process. So if it's the same variables, if they're both a terms, you're going to add the a terms only. The b terms, you'll add the b terms. So first we're going to start by multiplying the coefficients. So negative 4 times 3 is a negative 12. And then I'm going to look at my a terms. My a, I have a 3. And then I'm multiplying here so I can add these. So 3 plus 2, that's going to get me 5. And then multiplying, I'm going to do 1 plus 5. 1 plus 5 is 6. Okay, so same idea, it's just extra variables. So don't get thrown off by that. It's the same process. So for number 24, same idea. We're going to multiply the coefficients first. Multiply those coefficients. Negative 7 times negative 4 is 28. And then you're going to go ahead and add the coefficients here. So 9 plus 2 is 11. 3 plus 6, because they're both Q's, 3 plus 6 is 9. And then for R, we have a 1 and a 4, and that's going to be 5. Try 25. For 25, you're doing 8 times negative 3 first to get negative 24. Then you have your two x terms, which is a 4 and a 4. 4 plus 4 is 8. And then for your y terms, you have a 2 and a 9. 2 plus 9 is 11. Okay, so same idea for the next one, just now we have 3 different monomials, which is okay. We're going to multiply all 3 of the coefficients, and then you're going to add all 3 of the exponents. So 2 times negative 5, that's negative 10. And then negative 10 times 3 is negative 30. So I'm going to have negative 30, and then you have a 1 here. So 1 plus 2 plus 3, that's 6. So my answer is just negative 30, y to the 6th power. Okay, so we're going to go ahead and do the same thing here. There is a 1 as our coefficient here, so I don't need to worry about that. 6 and a negative 1. So 1 times 6 is 6. 6 times negative 1 is a negative 6. And then my a terms, I have 1, I have 5, and I have a 1. So 1 plus 5 plus 1, that's going to get me 7. And then the b term, I have a 1 here and a 1 here. So 1 plus 1 plus 1 is 3. Okay, so remember, these rules only work when you're multiplying and doing no other operations. Okay, so 28, same idea. We're going to multiply our coefficients first. So negative 2 times 1 is negative 2. And then negative 2 times 3 is negative 6. My x terms, I've got a 1 here, I've got a 1 here, and I've got a 2 there. So 1 plus 2 is 4. And then for the y's, I've got a 1 and a 1 and a 3. So 1 plus 3 is 5. For number 29, it's a little bit different here. So we have our 6 times 7 times 1. Okay, 6 times 7 is 42. 42 times 1 is 42. And then we're going to multiply our m terms. So I've got my m to the first and my m squared. So it's going to get me m to the third. And then I'm going to use my n terms. So I have an n here and an n here. So 1 plus 4 is 5. And I can go ahead and combine all these. Since you're multiplying, they all combine together. So for number 30, we're going to go ahead and multiply our coefficients. 8 times 10 is 80. 2 plus 3 is 5. And then 1 plus 5 is 6. Okay, for number 31, we have our coefficient of 4 here. Yes, there's a parenthesis here, but the coefficient is still 4. So we're with the negative 4. So we're going to take negative 4 times the negative 5 to get a positive 20. And then I've got r, which is the first power, plus 4, so r to the 5th. And then that's to the first power, and this is second. So 2 plus 1 is 3. So for the next one, same idea. There's just a fraction, so don't be thrown off by fractions. So for the first one, you're going to do negative 6 times 1/2. 1/2 of negative 6 is negative 3. And then we can add our exponents. So 2 plus 1 is 3. 1 plus 1 is 2. Try number 33. So for 33, you're going to do 12 times 2/3. 2/3 of 12 is 8. And then we have the exponent of 1 for our y here, but there's no x. There's only one x, so I'm going to keep the x. And then for the y, I've got y to the first and y to the fourth, and that's going to be y to the fifth. For number 34, you can go ahead and just do 1/4 times 8 times negative 6. So 1/4 of 8 is going to get me 2. And then 2 times negative 6 is negative 12. And then these are all exponents of 1. So the 1 plus the 2 gets me m to the third. And then 1 plus 2 gets me n to the third. Okay, so you're going to go ahead and do these next 4 questions. Whenever you have this operator in the center, you're going to do this side, and then you're going to do this side. And then once you do that, I'll show you, but you can also combine from that point. So there could be multiple steps here. So I'm going to start with this one. I'm going to multiply my coefficients first. So 2 times 4 is 8. My exponents of x's, I have a 5 and a 1, so that's 6. And then y is a 2 and a 3, so that's 5. Okay, so then I put my plus sign because I can't do anything with that. So if my exponents over here are x to the 6th, y to the 5th, that means I can go ahead a step further and combine my like terms. But if they're not the same, I would stop and leave my answer as is. So let's see if we're going to get the same number. So my coefficients, I have a 1 and a 3, so it's going to be 3. And then my x to the 4th, x squared, that's 4 plus 2 is 6. And then y to the 4th and y to the 1st, 4 plus 1 is 5. I do have like terms here with my x to the 6th, y to the 5th. So I can go ahead and just do 8 plus 3 to get 11, x to the 6th, y to the 5th. Try 36. When you go ahead and solve 36, you should end up with 28 to the 4th, b to the 6th, plus negative 2, a to the 4th, b to the 6th. And since my monomial expression right here, the variables are the same, I can go ahead and do 20 minus 2 to get 18, a to the 4th, b to the 6th. All right, so same idea for this one, except for now we have subtraction. So try 37. For 37, this one's already solved, so it's 19m to the 8th, n to the 8th, minus 4 times 3 is 12, and then m 5th, m 3rd, 5 plus 3 is 8, n to the 1st, n to the 7th, 1 plus 7 is 8. So they have the same variables, so I can go ahead and combine these like terms. 19 minus 12 gets me 7 m to the 8th, n to the 8th. Okay, try the last one. For this one, when you multiply, you should get 15 c to the 5th d squared minus 14 c to the 5th d squared. And since it's subtraction, I do 15 minus 14 because those are the same variables. 15 minus 14 is 1, so I can just write it as c to the 5th d squared. If you want to put the 1 in front of that, that's totally fine, but this is the most simplified version.